So we looked at some problems in the previous video, and this is the part 2 to that video where we'll be solving some more problems which are a little more advanced, you could say, compared to the previous ones, and you will have actual real life examples instead of just simple beams or rods or planks. So let's get started right away. The question says that the articulated truck shown on the left has two parts: the tractor, which has the cab, engine and the driver. So the red part is actually the tractor, and the trailer, which is shown in gray. The trailer is the part which obviously carries the load. Use information in the diagram to answer the following. Part A asks, what force does the trailer exert on the hitch? Now this is an important question. What force does the trailer exert on the hitch? Now remember, trailer is on top of the hitch. This is the hitch, right? So the only direction that the trailer can exert force on the hitch should be downwards, right? But the problem here is that you can't tell the value of this force unless you also know what force the hitch is applying on the trailer. So this is basically related to Newton's third law, and there's a whole video, a very long video on that specific topic. You can go and watch that one if you don't remember it, but it just says that forces always exist in pairs. So if one object applies a force on the other object will also apply an equal and opposite force on the first object. Now this problem is designed such that you can't really find the force which is asked in part A directly. You can't tell what force the trailer is applying on the hitch. However, by using the concepts that are learned in this chapter, the conditions of equilibrium and the principle of moments, you can actually find the force that the hitch is going to apply on the trailer. So we can actually find this force, which will actually be equal and opposite to the force which is asked in A, since they both apply equal and opposite forces on each other. So in order to find the answer to part A, first we need to draw that force as already done in the diagram. Now we also need to realize what other forces are acting on this trailer. The first and very obvious one is the weight of the trailer. Now where does the weight of the trailer act from? We know it's 200 kilonewtons or 200,000 newtons, but where should I draw it from? Should I draw it from here because it's written here? No, that would be wrong. We know that the weight of any object always acts from its center of mass or center of gravity. So this is where the weight is going to be, which is going to be 200,000 Newton. You also need to realize which point you should take as the pivot. Now if you think about it very carefully, it's the bottom of this tire. It's the bottom of this tire which can act as the pivot for you. The hitch can itself also act as the pivot, but since we want to find the force at the hitch, it wouldn't really help us to take the pivot at the hitch, because then the moment of that force is going to become zero. It will have to multiply it by 0, and we would not be able to find F. So it makes most sense to take this wheel as the pivot, since this is the point of contact of this trailer with the ground. So now we know all the forces that are acting on the pivot. There are other forces as well that will be dealt with in part B, but this is enough information to solve this problem. So let's get on with it. You have two forces, you know the pivot, you know the distances, and all you need to do is apply the principle of moments, which is one of the conditions of equilibrium. Since the trailer is horizontal, it's not rotating, we can say that clockwise moment will be equal to anti-clockwise moment. So what moment does the force F apply if the wheel which is at the rear of the truck is the pivot? Well, that will be a clockwise moment. This force is actually going to apply a clockwise moment. So we can say F, which is not known to us, multiplied by the distance from the pivot, which will be 4 plus 6 10 meters, and then this 200 Newton force is going to apply an anti-clockwise moment about the pivot. So 200,000 multiplied by 6, which is the distance from the pivot given on the diagram, and all you need to do is just find the force F. So the real skill here is just to make the equation in the first place and to realize where the pivot is, what forces are acting, how to apply Newton's third law in these situations. That is the real skill. Solving the equation is very easy. The equations are not that hard. Making the equation to solve the problem is the real skill in this chapter. So we can easily find out this force F. 200,000 multiplied by 6 divided by 10, and that gives us 1 2 followed by 4 zeros, so that's 120,000 Newton. That is the force, which you could also say 120 kilonewtons. That is the force which is acting upwards on the trailer. But the question was asking, what force does the trailer apply on the hitch? So since you know Newton's third law, the answer to that question is also the same. It's just that the trailer is going to push the hitch down and the hitch is going to push the trailer up. The forces will be equal and opposite. So this is actually your answer to part A. Now let's try and attempt part B in this question. That says, what force do the rear tires exert on the road? So now the question is, what force do the rear tires exert on the road, the point which we took as the pivots? Asking what force is this tire exert on the road. And let's call this force, I don't know, let's call this force Y. What force would that be? And again, you need to go back to that Newton's third law. Since we are using the trailer as our object, that is the body that we are interested in, you have to analyze the forces which are acting on the trailer. You don't apply the you don't use the forces which are applied by the trailer, but those forces are necessary to solve this problem which are acting on the trailer. So just the same concept that we used in A will be used here again. If the tires are applying force on the ground, the road will also apply an equal and opposite force on the tire. So instead of making this force downward, what I'm going to do is make an upward force like this, and let's call this force Y. And now this is the force that we need to find. This is the force that we are interested in. And the question, again, we can apply the principle of moments, but this time around you need to realize that you can't take this point as the pivot. Why? Because the force that you need to find is right at this point, and we know that if you take a force at the pivot in a moments equation, it gets multiplied by 0 and then it disappears. You can't find it. So either what you can do is take this point, the hitch, as the pivot and then solve this problem, or there is another easier way to solve this problem. Once you have all the forces on an object, remember in the first part we didn't know all the forces. We did not draw every force which was acting on the trailer. We had ignored the force Y, or we didn't need it at that point. But once you have all the forces available to you in a situation like this, there is no other force acting on the trailer. These are all the forces. This is it. So once you know all of them, you can apply the other condition of equilibrium, which is about forces. Since the trailer is stationary, it's not moving up and down in a vertical direction, so the forces in vertical directions are also balanced, which means that all the upward forces should be equal to downward forces, and that is what will help us solve this problem. Upward forces should be equal to downward forces, which means that the 120 kilonewton force, or the 120,000 Newton force, which is upwards, plus the force Y, which is also upwards, should be equal to the downward force, which is 200,000 80,000 Newton force. So this makes Y 80,000 Newton, or you could also say 80 kilonewton force. Now this is the force exerted by the road on the tires. However, the question was asking about the force which the tires exert on the road. And again, to reiterate, according to Newton's third law, that force will be downwards, but it will be the same size. So we're done with this problem. Let's look at another one. The diagram on the right shows a model crane. Right, so we can see the picture of the crane. The crane has a counterbalance weighing 400 Newton. There it is on the right hand side, it says 400 Newton, which can be moved further. So this can be moved further or closer to O. Remember, O will act as your pivot, so I'll just circle that point. To cope with different loads. With no load, counterbalance, the top section would balance at point O itself. So they're saying if there was no load here and the counterbalance wasn't here, the top section would balance itself. So we don't have to, basically what they're saying is you don't have to worry about the weight of the horizontal beam itself. You just have to worry about the counterbalance and the load on the left hand side, because without them this situation are already balanced. What we actually need to counter is the load on the left hand side. Part A says, with the 100 Newton load shown, how far from O should the counterbalance be placed? Right, so they're asking, if the 100 Newton force is 2 meters from the pivot, then how far should this 400 Newton load be from the pivot? Remember, this 1 meter load is not really useful to us right now, because we actually need to find the distance on the right hand side. And again, since you have to balance the crane, you can apply the principle of moments, which is anti-clockwise moment should be equal to clockwise moment. So according to that, the 100 Newton will apply the clockwise moment, which will be 100 multiplied by 2, and the 400 Newton will apply the clockwise moment. However, we don't know the distance, so we'll just say D in its place, and you can find D from the equation, which will be 200 over 400, and D turns out to be 0.5 meters, and that should be the answer to the first part. Now let's do part B as well. It says, what is the maximum load the crane can safely lift? Well, the maximum load that you can lift actually depends on how far you can move this counterbalance, because that's how a crane works. You move this counterbalance left or right, and this varies the amount of clockwise moment that you can apply. So the furthest you can move the counterbalance from the pivot is actually at this point. You can bring the counterbalance to this point. This is the furthest you can get away from it. So what we'll do is we'll take the 400 Newton force from here and we'll actually move this here. So let's assume the counterbalance is now in this position. This is the furthest it can go from the pivot, 1 meter. Then the question is, how big could this load be? So right now it was 100, but now since we have increased the clockwise moment, the anti-clockwise moment can also be increased, or the load can also be made bigger. So let's just forget about this and let's just ask, what could the load be? Let's just name this force F that we can apply downwards. Again, since you are balancing, you're talking about the balancing of the crane, you have to apply the same condition, anti-clockwise moment equal to clockwise moment. And according to that, if your clockwise moment on the right hand side is 400 multiplied by 1 meter, then the force F that you can apply, which is 2 meters from the pivot, should be 400 divided by 2, and that should be 200 Newton. That's the biggest load that you can apply.